it's recording. Yeah, so I will go to templates and then I will go to blank map, and then this is how ArcGIS will look like when you start. So ArcGIS is like any software that has a good user interface. Like if you work with tab and tabs, it will have some tools, files. So let's navigate this very quick. So first you'll have file, edit, view, like any software. File, manage files, you open new files, you create new files, you export files, export data. So all this from file, and the same thing, edit and view, keep it changing, many views. All right, so let's see how we can start with this one. So let's see how file look like. Like file, same thing, like new, open, save as, like any software. And it has something unique, which is add data. So we can add data from files. This is something that you like never see from any other software, because this is what ArcGIS is doing. It's data. So we can add data. And if you look at add data, it's like a mark like plus, and you can find it outside here. Like you can find add data here. Like all the files, like all the file tab here, it has new, open, save, everything until you come here at add data, which is the same thing like here. This gives you a quick access to visualize or to process your data. Okay, so this is the first thing. And edit, since we don't have anything yet, we don't have any models, but edit, like any editing, like if you want to redo, do, cut, paste, copy, do all, delete data. So that's what edits usually do on these softwares. And for view, like if you want to view some data, if you want to view a layout of your data, view some maps, this is what view is doing. We are gonna see how we will do this when we have some maps and we do some things here. But the most important thing for ArcGIS is the Arc Toolbox. So what is the Arc Toolbox? Arc Toolbox is what is the doing processing for the data. So that's actually what is the most important thing about ArcGIS. You guys can see. It's much better now. Yeah. Okay. So this toolbox, actually, I use, like, to be honest, I have been using ArcGIS for more than 5 years. And I can say that I only use maybe 5 or 10% of the capability of ArcGIS. I don't know, maybe like 80% what is these toolboxes doing. Because they have lots of things that I don't want to use. Like I only use things that it helps me with my modeling. I don't have to know everything about these toolboxes. So for example, I use maybe 3D analyst tool, some analysis tools. Every one of these tools has multiple tools inside it. Like let's open one of them. Like let's open the most important one, which is the data management tools. So can you see the data management tools has lots of tools that you can do. And each one of these tools, like for example, if we come to projections and transformation, it has lots of things. So that's what I'm talking about. I use this tool, like not all of them, like I used some of these tools. I used maybe projections because if I have a map, and like, for example, you have buildings and you have networks. Everyone has different projections. Like when you download this data from a website, this one is projected on like a sphere, and another one is projected on a cylinder. And when we will talk about projections right now, you need to put these two different data at the same page, at the same projection. So you need to project your data first and bring them to the same projection. So I have to go here and do some data management analysis, which is projecting my data. So that's what is the toolbox is doing. In this toolbox, we will do lots of data analysis. For example, if you have a raster map of the flood depths or a raster map of the wind speed, and you have your building on a second layer, you want to extract the wind speed at each building. This is what these toolboxes is going to do. So you will give this a toolbox, you will give the raster map, the hazard map, and you will give the building layer, and you will ask the toolbox extract the hazard intensity at each building. And that's what these toolboxes is going to do. Okay, so let's first start with, do you guys remember when we talk about discrete data? So let's see an example of discrete data. So I have what is called shape files. Shapefiles, as I told you last time, it's the data structure that can have discrete data, such as points, polygons, or lines. Do you guys remember polygons or points? If we want to represent a building with a point. Polygon, if we want to represent a building with the entire polygon of its boundary. Lines, if we want to represent a network. Okay, so this is the shapefile. So here I have a shapefile, polygons, and let's add them here in this space. Okay, I have two of them. Okay, so to add data, first I will come here at add data, or you can come at file and say add data here, and you'll come here add data. So to add data, you need to make connection with the folder that you want to add data from. So here you'll find a plus sign on a folder, which is connect to a specific folder. I'm going to click on this and I will go search for my folders. So I will go to my laptop. Here's my computer. It's my folder name, and then I will go to FIU, then classes, my class, and let's connect to this folder. So this folder has lecture number 9, which is the lecture of today, and this is the shapefiles, and I want to add this shapefile. Actually, this shapefile is for a city called Galveston County, city in Galveston County, which is the Galveston Island. And this is for the building polygons in this city. So I will say add, it will take some time. Okay, so this is a polygons. Let's make a zoom in on these polygons. I will click on the zoom and then I will zoom at a specific bar. Can you see the blocks? All this. So each polygon of these is a building. Like this is a building, this is a building, this is a building. But actually to enhance our visualization of these buildings so we can add some reality, ArcGIS gives us the ability to make to have a base map under these buildings. So what is the base map? Is like you can have, if you have like Google Maps, you can see the base map of Google Maps. You see that you are moving in the maps. There's different maps that we can use, but there is one of the maps like Google Earth maps, Esri base maps are very good when we need to visualize. So if you want to add these base maps, you'll go to add data. Once you add your verse shapefile, these two is going to be activated, add base map. So when you add a base map, it will open many base map that you can choose from. Actually, I'm always go with the imagery base map because it's much more realistic. However, some people say, okay, it's a very dark for my data. How about I will use a streets base map or topographic base map? You can try them all, but let's try imagery here. So it takes like a few seconds until it loads the maps for my city. And once it's loaded, you will find actually the location of each building within the city that you are talking to. So here, when we added the base map, it told me that the base map are gonna be at the world of imagery, the base map that I'm gonna add, it will be having the geographical coordinate system. GCS is geographical coordinate system. It's called WGS 1984. So WGS 1984 is the coordinate system that we are gonna use in most of our data. However, some people prefer to use different coordinate systems. So this is called World Geodetic System, and it's a way that we present our data. Okay, so we will not talk much about projections, but might give you some ideas about it. But we are gonna use this kind of projection in all of our classes, and it's the most used most used coordinate system in all the GIS applications. Okay, so I will say close. That means like, okay, I agree. So if you open the layers and if you click on layers and you click on properties, you will find that you're like, okay, you will find that the coordinate system that all right. Let me click on properties for base map. Okay, so right now my Galveston Island is on different projection actually. It says that the projection is the National American Datum 1983 state plan, but this is projected coordinate system. So there's difference between when we talk about geographical coordinate system and the projection. But we are not gonna go in this debate right now. But I just want to know that that my data is projected on like a specific, like, you guys remember when you take geography and we will talk about projections, like you can having your map projected on a cylinder or having your maps projected on a cone or in a ellipsoid. So there are different many projections that we can talk about. We can change between them, but this is not what we are gonna focus on this class, but what we are gonna focus on the side of the data. But you will have to keep sure that projection sometimes is very important, and you cannot do some of the data processing until you have a consistent projection between your data. Like, for example, when we do hydrologic analysis, and we have many maps, like soil maps, land use map, digital elevation map. If you have one of these have different projections from the other, and you try to merge them to do some data analysis, the tool will be confused. Like, these have a different projection. Each one is on different space. We cannot do the processing. But right now, let's assume that we are going to use same projection, the National American Data, as a projected coordinate system. But all my latitude and longitudes are in geographical coordinate system, which is the GCS North American. So we are going to use this projection during the class. Okay, so this is my data. This is all my buildings. Assuming that all the projections is fine, and I'm gonna use this as my projection. Can you see the buildings is getting smaller? How many buildings that we have? It's too many. When I zoom out, you cannot see anything. Actually, the island is very big. If you want to zoom at the entire island one at a time, you can click on your shapefile and you click on zoom to layer here. It will make a close-up view on your entire data. And actually, my data is just this island. This island is called Galveston Island. It's in Texas, on the Gulf of Mexico. It's one of the part of Texas that are exposed to lots of hurricanes. It was the ground zero of Hurricane Ike in 2008, which caused lots of devastation on this island. All right, so this is Galveston Island. Let's check what is inside these buildings. You will say, okay, this is polygons. I just have geometry. Where is the data? I want to know if this building is residential, is it commercial? What is the number of stories? What is the foundation type? You want to know all this information. How can we know it? This is what is inside the shapefile. So if you click on the shapefile, right click, like this, you can open what is called attribute table. The attribute table has lots of data about these buildings. Like if you open it, the attribute table, this table will be outside like this. I usually, just to organize my screen, I make it docked down like this so that I can see the buildings and also I can see the table. Look at these buildings. All this are data about these buildings. So each row represents a building, like building number 0, 1, 2, 3, 4. FID is the local ID that GIS give it to your data. But actually, there is a special ID for the building that everyone knows, and it doesn't change if you put this data, if somebody's using this data in Texas or Oregon or any state. And this is called object ID or building ID or parcel ID. So the US is divided into, as you guys know, into states, and there's what is called census tracts and census blocks and parcels. So this is how is the data, how is the how US is geographically identified. Like it's like something big. This is the US, and then the US is some states, and with the states there is counties. Something like this. Within the counties, there's census tracts, very, very small. Within the census tracts, there is called census blocks. Within the census blocks, there is parcel. But when you have a building, this building is on a parcel. The parcel is the entire land. that has the boundary you're building. Sometimes like you are in, like you have a hospital that has 5 or 6 buildings. These 5 or 6 buildings belong to the same parcel that for the same hospital. So a parcel can have many buildings, but a building can only have one parcel. Like you can have parcel, and this parcel has many buildings, building here, building there, like 5 or 6 buildings. That's why it's better to have building IDs rather than dealing with parcel IDs, because all these 5 buildings are gonna have the same parcel ID. This is part of the data organization. Why? Because when we want to link data together, so we want to link based on a unique attribute or a unique ID, and want to have each building has a unique ID. And sometimes actually we go very deep inside the building. What if you have a multi-family building, not a single family building that has lots of buildings, like we have unit here, unit here, unit here, unit here, like you have a multi-family building, have 8 units. So we go with housing units, not only a building. So we can go very, very deep inside our data. So here, like you have a parcel ID, you have the shape length and the shape area, like it tells you what is the area of the building. You have the latitude and the longitude of your building area, the building value, the number of the story of the building, like it tells you this building is 2-story, 1-story, 1-story, 2, 15-story. Building use, commercial, residential. Sometimes the occupancy is given a number, like this is an occupancy. If you see the commercial has 165, so all the commercial buildings are given the same occupancy number, but when it comes to residential, say it's a different numbers because it's different occupancy. Why we need the numbers? Because when we do some programming, we sometimes like say if the building is commercial, give this archetype to this commercial building. If the building is residential, give this archetype to this building. But we cannot say if commercial, because when we do if statements, we need numbers. If the building has the occupancy ID 165, give it this archetype. We cannot say if it's commercial, okay? Same thing, like here you have, this is like a post-processing that I did after I have this data. Like here, I assigned an archetype to each one of these buildings based on the information that I know. So for example, I know that this building has foundation type, a specific foundation type, and have a specific number of the stories, and have many other information. And based on this, I was able to know that this building is archetype 6. And when the archetype 15. So I was able, from the information that I have about these buildings, to assign archetypes. So this is just like a brief overview. What is this attribute table have? Like have all the data about the buildings. Okay, so let's see, what if a building is missing? Like, let's actually zoom on this, zoom to the layer, and let me go here. Okay, I want to zoom and try to find area that has a building is not modeled. It's a little bit, it takes some time. But what I want to do right now, I want to edit the shapefile. Like I want to teach you how we can edit the shapefile or even create a shapefile. So what I'm gonna do, let's assume that I have a polygon for this building, a polygon for this building, but I found that this polygon, this building doesn't have a polygon, and I want to create a data for this building and add it to this shapefile. So let's see how can we do it. I'll just like let's zoom again, zoom to the layer, and Okay, so I'm gonna do like a very quick example. So if I want to edit a shape file, you will go to editor and then hit start editing. If you didn't have this bar, you will go to customize toolbars and you will search for editor and you click on this. So the bar will come outside and then you pin it to the top tools here. And this is the case for any toolbars. Like if you want HEC0, HMS, Arc Hydro, any of these toolbars, you can pick whatever and then put it up there. I usually put editor files, not all of them. I only put the things that I need up in this toolbars. Okay, so I'll hit start editing. Okay, and right now I can edit, like I can't see from this bar. Let's put it down here. All right, so here in this toolbar, oh, it's very heavy. Let's see. Okay. All right. So if you want to like do like a line, for example, let's enter. I'll go to, where's the laptop? Classes. Selecting. Okay, so let's just start with this one. So you can select this one. And then you can edit, like you can edit if you find like this one is not matching, you can edit this one and get it here. You can move the points. You can do lots of things here with this one. And actually you can add points. Like if you want to add points on this building, you can add another point here and another point there, and you can stretch this point. But actually, in most cases, we are not gonna do this with our buildings. I'm just like, want to show you what you can do with edit. You can sketch new properties, you can add, like here, this one, you can add polygons, you can click on rectangle, and then you start make a rectangle, something like this. Did you see? You go to sketch here. And if you did something, if you want to stop editing without saving, you will just stop. I will ask you, do you want to save your edits? I will say no. So everything that I did will be gone. If you want to go back and do editing, so you will start editing, and then you will go, if you want to draw a building, like you recognize, I can see, I see all the buildings here are well recognized and captured in the polygons. But let's assume that there is multiple buildings beside this one. You will go here, sketch properties, you will find it's the only shapefile that we have here is Galveston island buildings. And then you can draw polygons as rectangle, or like, for example, you can make one line this way, and then you make a building like this. Or you can make it a polygon, like point by point, like you will go something like this, like this, and then you will right click and click on finish sketch. So it will be a building like this. But when you draw this building, it will have no data. So you will have to click on this building on the attribute table and put the data for this building if you know it. If you know the first floor elevation, the building value, the number of stories, you'll have to know all of this data.
So for the whole island, when you do it, you go one by one and you do.
No, actually, no. For this, the Microsoft buildings, they used image processing. They map all the building in the entire US, 150 million building. But this data has no data. It has only the shapes, only show you. This is a polygon, but it doesn't say you, because it only do image processing from the top, which recognize the edges of the building and then makes these polygons. But the data, like people, can use this as a base and they start to enter the data.
So you enter the data for the building one by one?
Yeah, I did actually this for many communities, like, but it depends on how many data that you want. And actually, like, let me tell you, some of the communities in the US has very rich data. Like if there is North Carolina is the only state that has data for each building inside their communities. Actually, I have like a 5 gigabyte shape file for 10 million building in the North Carolina that tells you how many nails inside in the shingle on the roof of each building. What is the seismic zone? What is everything you will find in this? But other cities doesn't have any data. So you will have to do it by yourself. And actually I did it for Waveland, Mississippi, like 3,000 buildings. Like what we do actually, you will go, like, for example, assume that we don't have any data. You will go to Google Earth. Because this is important to know, like how, if you don't have data, and since the countries are very small, like Mexico Beach, Florida, it has like 400 buildings. You can do it in like a couple of weeks. You go building by building and navigate them and collect the needed data about this building. So let's put here Mexico Beach, Florida, and search. Okay, so this is Mexico Beach, Florida. You will find that the buildings, all of the buildings are damaged. Like you cannot find buildings to collect data about, but this is from the top. Like I want to know what is the properties of these buildings before the hurricane hit and damaged these buildings. So you will grab this little man, the cruiser, and the streets will show up that has Google Street Map view. And then you will put it here. And once you hit down, it will show you how this community look like, but when, which is very important. Like how we need to know when this maps were taken. It was in 2011, which is very long time ago. So we can escape this and go to Google Maps, not Google Earth. Google. I'll teach you a tricky thing. Mexico Beach, Florida. Right, so this is Mexico Beach, Florida. Let's make it satellite image. And you'll come here. You'll put the cruiser. For example, let's put it here. Right, I'll put it in this street. So it will show me how does this street look like. And let's put it here. Okay. picture, it's in 2019 after the hurricane, but we want it before that. Let's spot that here. Okay, it shows you here many dates at this streets. Can you see down there? Okay, can you see here? This is how this neighborhood looked like in 2007, 2009, 2011. Let's go just before the hurricane. Actually, there's a recent picture, a recent street view in June 2015, which just like before the hurricane with 3 years, which is the best way to assess the level of this building, how it looked like before the hurricane. Look after the hurricane, just a few days, because Hurricane Michael was in October 2018, how it looks like. It was something like this just after the hurricane. And actually, I can assess damage from what I see here. But when I stepped, actually, because when you switch your location, like when I was here, that means that there was a car here that captured an image at different location, because this is a main street. But when I moved here, the side streets has less imagery. So it was 2019. So that's what happened when you switch. So I will go back at this point where we have many Google Street Views. Yeah, here at this point. And I will look at October 2019. This is how the street looked like. And this is actually the best way to do damage assessment during a hurricane, just before the hurricane. Look, a month later, in November 2018, how does the street look like? The cleaning start. So if you, and actually this is one of the studies that we are working on the recovery of this city. This is the best way to track the recovery of the city. You look at the images and see how this building is recovered. And in October 2018, it was a mess. And then 1 month after, the cleaning started. So we know how much the cleaning took, like a month. And then you'll see in September 2019, like 1 year after, if you look here, you will find after 1 year, from what I can tell, like the buildings are maybe recovered or the recovery may not start yet. Let's click on the other year, October 2020, and see how these buildings look like. Where is it? Actually, it's a different location. Yeah, look at 2021. Look at these buildings, how it look like. Is it the same one?
Yeah.
No, it's completely recovered. Can you see? This is how you can monitor the recovery. There's a people live. So that's why we monitor how we can monitor the recovery. It will be extensive processing, like you will have to do it building by building to track the recovery, but it's worth it. Like if you want to build a recovery model for an entire community, you make a community of 400 buildings, and then you navigate them. While you are sitting on this building, you can keep adding the data for this building. This is the case in 2018, this is the case in 2019, and this is how the building over time look like. Yeah, let me get back here. I think I put the shape files somewhere here, but anyway, let's get back to this one. So this is how I showed you we can get some data about the buildings. Also, let me teach you another thing. In Google Street and Google Earth, there's a way to know the floor elevation, which is very, very important when you do flood risk analysis. Because if you have, this is a ground elevation, but your building is elevated to this location, so the damage will not hit the threshold until it will be more than the vertical floor elevation. Most of the buildings in the US doesn't have vertical floor elevation, except North Carolina has vertical floor elevation data for the buildings. But if you want to get it for a specific community, and Google Earth can give you an accurate vertical floor elevation, like not accurate, like 1 feet accurate. Can you see my cruiser here? You will find here a number, it's called 15 foot. Okay, so when I put my cruiser on the ground, that means that my ground is 15 foot from the mean sea level. And actually does make sense, because Mexico Beach is around this number, like 3 meter, 5 meter from the because it's a coastal, like it's very close to the sea. So when I come to this building and put my cruiser at the first step, it says 16 foot, which makes sense. Like it's around 15.5, 16 foot. Let's go to this building over there, which is elevated. Yeah, this building is elevated. If you want to know the first floor elevation, you put your cruiser here, you try to tweak it from different location. Go here. All right, so what happened right now, this is one of the drawbacks when you use Google Street Map View. You move, it keeps switch the street views that has been taken. Like I went right now to a location that doesn't have a street view from 2005, but it has a street view from 2020. So it switched you to another street view for the same street. This like street view from 2021. So if you want to go back, I will scroll back here. Okay, let me exit and then exit grounds. And let me get back again. Yep. So this is how I know the first floor elevation. You put your cruiser at this location. Sometimes it's good, sometimes it's bad. Like here, it says that the elevation is 8 foot, but when I put my cruiser here, it says 16 foot. So when I put it here, it's 18. Here it's 16. So the difference is 8 foot. So it makes sense. Like it's like from 8 to 16, it's 8 foot, which is almost 1 story. Maybe it's 9. Okay. So the accuracy is 1 to 2 foot, which is good. It's not bad. It's better than nothing. Yeah. So this is one of the things. And if I want to add this data into my model, like let me stop editing so that I don't mess with my shapefile. So I go to my shapefile and add this data. How can I add it? You will have to go to editor and do start editing. And then you open your shapefile and then edit your shapefile, because without editing, you cannot change values in the shapefile. So for example, if you identified that a building, a number of stories is not 2, it's 4. So you will click 4 and it will add 4. Right? And then you hit save and then you close the shapefile and you keep changing everything. You can do this with any field here. So let's get this back to 2. I'm just like making an example. And when you add a new building, like if you added a building here, for example, let's assume that we need to add a polygon, like a rectangle polygon here. Yeah, I will show it to you in a second. Okay, so I added a building here, and then I will. Yeah. And then I will stop the editing. It asks you, do you want to save your edits? I will say yes. So right now, this building is here. So if I want to add data for this building, you can select, like this is how we select buildings. You can click on this and select this building. And in my table, my attribute table, you will find one building selected out of 29,000 building. So if you click on this one, it will show you the data for the selected building. So this is the data for my selected building. It has zeros everywhere, has 0 data. However, if I select this building and I went to the data, you will find all the data about these buildings. So I will select this one. If you want to edit the data for this building, I try like to click on this and try to add data. It will never click until you go to editor, start editing. Now you can edit. Without start editing, it will never edit until you start the editing process. Okay, so let's delete this building. All right, the editing. And then I click on this one, select building, and you will find I can delete it until also I start the editing. So you will click on this building and then delete selected, and it will be deleted. Then I will stop editing, and then I will, yes, save the edits. So what I draw, I delete it. Okay, so this is how we can add data on this. What if we want to add a column to your data? Like, for example, you have the water surface elevation, and you want to calculate the flood depths. So, for example, this is my city, something like this, and it got flooded. Like, this is the water, and what I have is the water surface elevation. What is the water surface elevation? It's the elevation of the water from the mean sea level. So it can have a big number, like the water surface elevation can be 119 foot. This doesn't mean that my city got a 119 foot of flood depths. This is the elevation of your flood measured to the mean sea level. And your ground has the ground elevation from the mean sea level is like 110 foot or 106 foot. Okay, mean to the mean sea level. If you want to calculate the flood depths, you want to subtract the ground elevation from the water surface elevation, like the flood depths will be the water surface elevation minus the ground elevation. So you will subtract, but the thing is, I'm calculating this at only one point. Every part of the ground has different elevation. So each building has different ground elevation. So I want to do this for all the buildings. Okay, let's do an exercise here. So I will come here. Let's see if I have various flow elevation. Okay, I have water surface elevation data. Oh, but it's empty. Okay, let's create the water surface elevation. All right, let's zoom to this land and zoom to this layer. How can I know the water surface elevation for this area? I need a hazard map, right? Okay, I have a hazard map, and the hazard map will be a raster or a feature map. Raster, right? Because it's continuous data. I have a bunch of raster files. Wind velocity, maximum flood depths. Okay, let me get the water surface elevation. Galveston, Texas. Hazard maps and Hurricane Ike. Let's get maximum water velocity. Yeah, here's maximum water surface elevation. Let's get this map and go back and put it here. All right. So, and then I'll come here. And I will you will have catalog here. And in this catalog, you can open any files that you have. Like I have my class here, CGN 5930. And then I have my raster maps here. But if I open my raster maps, I believe I will not find the water surface elevation. Why? Because I need to refresh. I click and then I say refresh, and it's supposed to show, yeah, here's water surface elevation. And then you can drag it here. When you drag it, it will ask you that to build the permits. It's kind of process to add this map to the to your file. It will show up like this, like black and white. But if you want like this map to be having multiple colors based on the water surface elevation, you can click on this map and hit properties, and you will find something is called Symbology. And for the Symbology, you will have multiple colors. Like you can change it to be something like this. Okay, so this is how does this map look like. Zoom to the layer. Yeah, so this is how is the water surface elevation map look like. If you want to extract the value of the water surface elevation at each building, first we need to convert let's put the, okay, why is the buildings is here. So let's zoom on the buildings. Can you see the buildings? It's on the top of the maps. So sometimes like you have the maps on the top of your buildings like this. So you will not be able to see the buildings. If you want to see the buildings, you bring the map below the buildings so that you can see the map, the buildings on the top of your map. Right now, my buildings has polygons, babe. And to extract a flood depth or a water surface elevation at the building, it varies. Like, look at this pixel, has different value from this pixel and has different value from this pixel. So it will be very, very confusing. First, we need to convert these buildings into points. And the best way is to find the CGE of these polygons. This is the best way that we can do it. Let's see, learn a new thing, which is how to convert a polygon into points. It's a very easy. The easiest thing is you go to the search. So let me ask, what do you guys think? What should I use to do this process? It should be a tool, right? It should be the ArcGIS toolbox. So you hit this box, it's called Arc Toolbox, the one that I showed you at first. I usually make this box like here in this location because I will keep using it all the time. You just like click on this pen and you pin it on the side here. So, and then you keep searching for a tool that allows you to convert from polygons to point. Actually, I forgot the tool. What is the tool name? But I know there is a tool that do from polygons to points. So if you forgot it, it's a very easy. You go to search and you search poly to point or feature to point. Then you search, you will not find anything. How about we click feature to point? Oh, I wrote point wrong. Point, let's see. Yeah, I got it here. Let's search point. Yeah, feature to point. This is what we want. So feature, that means like if you have a line, if you have a polygon, you have a point, and you want to convert it to other things. So I will click on feature. Where is it? Yeah, feature to point, and it's actually in data management tool. Like you can find it if you want. Let me close this. And if you want, you can go to Arc Toolbox, data management tool, and then you will find features, and then you will go features to point. Can you see? But sometimes I forgot, like you don't know. Actually, there's hundreds of tools here. You definitely will forgot something. So what I always use, I go to search, and then search from like feature to point or whatever keyword that you can remember, and then you hit feature to point. So my input points, my input feature is the Galveston Island building polygons. This is the only shape file that I have right now. And I want my output, I will select the folder to be this folder, and I will change the name from poly to points. And I will save and I will hit OK. It will take like a few seconds and it will do the processing and it will convert all these polygons into points and it will keep the polygons. Here what we have. So if I zoom in, you will find that a point in the middle of each. Okay, let's see if the data is inside this point. So you will go to Open Attribute Table. You will find all the data are inside these points. So we didn't lose anything. The next step is I want to extract the water surface elevation at each one of these points. So you will go to the toolbox, and this is, far as I remember, it's this in a spatial analyst tool, and you will go to extraction, and in extraction you can extract value, extract by point. Extract values to points. But I usually use extract multi-values points. Why? Multi-values point, it doesn't create new shape file. It adds the value of the water surface elevation into the same shape file like this one. But if you use extract values to points, it will create new shape file that has the new data. But I want to add my data to the same shape file. Also, extract multi-values to point. You can add 3 rasters. Like you can add a raster for the wind speed, a raster for the circle height, a raster for the wave height, and you can put all this raster in the same toolbox and do the process in one time. And it tells you what is the value of the water surface elevation, what is the value of the wind speed, what is the value of the wave height at this specific point. Okay, so let's do extract multi-values to point, and then I will add my Galveston building points. Here's ask you about put point feature. The second thing, it asks you about the raster. What is the raster that you are going to use? This one. And then I will hit OK. That's it. It will take a few seconds. And then let's check what we have here in this data. I will go to an attribute table. You will find the last column. It's IC maximum water surface elevation. So a new column was created in my data, has the same raster name, and it has all the values of the water surface elevation at each point. Same thing with wind speed. If you have a community exposed to wind, and then you put the wind raster map and you have the building points, you can extract the wind speed at each building. So that's what we did here. Actually, you can change the name. Like, for example, I can go back here and extract multi-values to point. When you add the features and add this, you can change this. You can just name it water surface elevation, like WSE, and we will say that these values are in meter. So water surface elevation and meter, and then I will hit OK. So I have to close this raster file and then reopen it. Sorry, the shape file. This is called shape file, like this one, this is called raster file. So most of the features data are called shape files. So right now I have it meters and I have all these values, water surface elevations. Okay, let me check if we have ground elevations here, ground elevation data. Okay, I don't have ground elevations data, but let me check if I have a raster map. Galveston, Texas. Shape file search. Looks like I don't have. Okay, I don't have the ground elevation to do this subtraction, but let's see how we can do processing on this data. Like, what if, for example, you are not interested in the water surface elevation in meter and you are interested in feet? So if you want to make another column beside this, and you will call it water surface elevation feet. So you will go here and add a field, add field. And this field, we will name it water surface elevation underscore feet. And here it will ask you, what is the data type that you are looking for? I'm looking to write numbers. This number could be short integer or long integer, or can be float. So, okay, I'm not looking an integer number. I need it float that it can have decimals. So I usually use float or double. So I'm gonna use double. Double is the same. It can have decimals, and I will say, okay. Do you guys know the conversion from meter to feet? 3.2, right? Okay, so I will do a field calculator. So I will click on all this field, like I will click on the top like this, and here you will have field calculator, and I will say that this field is equal to this field, which is a meter, multiplied by 3.2, just 2, or I believe there is some decimal, but let's keep it 3.2.
Divide by 0.34.
Okay, let's divide 3. Point.
No, 0.3.
Oh, sorry, 0.308. 048. 0.3048. Okay, and then we will hit OK. and then you will get the values in feet. Actually, you can actually ask ArcGIS to calculate the latitude and longitude for each building. So I can add a field and I will call it latitude, and we will make it double. And I will add another field. I'll call it longitude. I will make it double. So the longitude is the Y, the latitude is the, sorry, longitude is the X, because longitude is this, and it has different X's, but the latitude is this one, which has different Y. So longitude is the X and latitude is Y, but I will name it latitude and longitude. And then let's fill this data. Like if you go to latitude, you can click on latitude, and then you will do calculate geometry. So when you calculate geometry, it will ask you what is inside the latitude. Is it X coordinates? Okay, you can check either X or Y. We just said that latitude is Y coordinates, and then we will make it in feet. You can actually change it to be decimal degrees, like what is the degree? And then we will make it decimal degree, and we will say, okay, it will take few time to calculate the latitude. And it will fill all this data. Longitude, you will add field, calculate geometry, and then you will go here to Y coordinates. Sorry, X coordinates, longitude, and then you will say decimal degree. Then you will say, okay. Then we calculate the X and Y coordinates for all my data. All right, so here, if you check the X, so Y latitude, latitude is 20, let's check. Latitude is 29.24. Here's latitude is 29.24. Longitude, the one that I have in my data, whereas, yeah, here's longitude is negative 94.85. Longitude is negative 94.85. So I was able to get the latitude and longitude. Okay, so this is how we were able to maneuver our data, how we calculate latitude and longitude, how we edit the shape files, how we add, because this is routine processes that we will do while do community level analysis. You need to have this experience. But let me tell you what, sometimes as a beginner, you will not be able to know everything about this whole thing. I still, like, whenever I stuck with something, you Google it or go to YouTube. I want to convert it from this to this. I want to change coordinate system. You will find 10 YouTube videos that shows you how to do it step by step. Like how to load two raster maps, how to merge two raster maps. Like sometimes when we download data from USGS, it doesn't give you the raster map for your entire area, like the ground elevation for your entire area. It gives you pieces. But okay, your area have 10 pieces. Like here's my city, like this, and what I was able to download as a raster map or as a digital elevation map is a map like this, and another map from here, another map from here, another map from. You have 4 raster maps, and you want to join them. So you go to YouTube and then ask the YouTube how to merge raster maps on ArcGIS. Find hundreds of videos, use them. It will be very, very quick. Or you can write on Toolbox merge raster maps, and then you merge. But sometimes when you watch YouTube videos, like, because there's some questions when you merge, it asks you what is the pixel size that you are looking for. Is it float, or is it like, do you want me to round when I do the merging? Like if you have a pixel that has value of 3.19, do you want me to round or I keep it unrounded? So you'll have many questions. When you watch a video, it will tell you how to do this process without any error. So this is just like an introduction on how to do data. Next time, I'm gonna teach you on like how to process this data in natural hazard modeling and risk analysis with some MATLAB coding. But I just like want to get you guys familiar with ArcGIS. So what I want you right now is to have your ArcGIS, familiarize yourself. I'm gonna send you like a homework. I will send each one of you, I know like we have 7 in my class. I will send each one of you a raster map and a shape file. And I will ask you to do some processes on this data. And also there is a homework that I'm still developing for the last 3 lectures. So I'm gonna include this in one homework, and then you will have to get your hands on ArcGIS because we are gonna use this in our project. Okay, all right, that sounds good. See you guys next time.
So I can have access through, you can have access through the EIS